Okay, hi, welcome back. So today I will show you how to design a PCB, just more towards tips. Okay. So for me, I prefer to use Express PCB, which is this one, and this is the old, very old version. So it looks something like this, and it's not exist anymore. So if you want, I share the link here, so you can scan this QR. Okay, to install the software, or you can just click the link here. Okay, this is the link. Okay, so this is very old software. If you try to search Express PCB, you will get the new latest one. This one, Express PCB plus layout. It's also a free software. Okay, so you can see here, this is the interface. It's much more different actually. Okay, let me. So you can see here, this is a new version, much more better actually. But since I start my PCB design using this old software, I use this one. Okay, so I discard this. So for this one, first of all, okay, when you want to design this, you have to know this, the size of your PCB. Either you want to put just random size, or you want to use a predefined size. Okay, so for this case, it is, I think is I forget already. Let me check first. Okay, it's 20 cm multiplied by 15 cm. So this is the PCB. Okay, so when you come to this design, make sure you make it smaller. Okay, cannot make, if the PCB board is 20 multiplied by 15 cm, you cannot make this as 20 multiplied by 15 cm. At least have a space. Actually, for the tape, okay, you need to tape this during the heat transfer process or printing process. You need to have a space. So for example, this is the size of the PCB. You need to have some sort of spacing. Okay, so that one. Or either you can make it smaller, then you can cut the board, no problem also. But for me, I don't want to cut the board, so I just follow the original size. Okay, for research, usually we don't care about the size, we make it large. Okay, easy to design. But if you want to do a product, you have to make it small. Okay, and this design is only single-sided, and this one is for DIP. Okay, DIP means that you have to drill a hole in the PCB. There are DIP or SMD. SMD you can do that also, but for FKE, UTM, we don't have the facility to do that. Okay, you need to have a different facility to do the SMD design. Okay, so SMD means that you just surface mounted device. Okay, the IP, you need to drill a hole. Okay, so that is the first thing that you need to consider. Okay, setting up the size and make sure it is either small, much more smaller than the PCB you use. Okay, so that is the first thing, and then the second thing, you have to put a PCB stand. So you can see here, this is the PCB stand. Okay, so you put the PCB stand. I suggest you put minimum is 4 at each side, and make sure you don't put too close to the the edge. Okay, so you cannot put like this, because usually it will break. You need to put a little bit deep into here. Okay, cannot put at the end. Okay, last time I do this, it can break. Okay, so I suggest put it a little bit inside. Okay, and then another thing is, if your board is too long, for this one is like I said before, it is 20 cm multiplied by 15, you should put another PCB stand. Okay, why? Because if you have a lot of component here, okay, or heavy component like inductor, it will bend. Okay, or maybe during the process it can also bend. So I suggest you can put another one here, maybe at here at the middle. Okay, but this one is not necessary if your component is low weight. Okay, So for this one is high wick, but my design is my inductor put it outside, so no need to worry lah for this. Or you can just put at the middle for PCB stand. Okay, in your design make sure you put PCB stand, okay, because if you put at the desk directly, okay, sometimes on the desk you have some sort of metal dust, okay, and it can short circuit the system and you can damage everything. Not everything, most of the component if this occur. So that's why, like it or not, you have to buy a PCB stand. It's only around 40 cents for one, okay. So that's why you have to prepare the PCB stand. So for this one, I suggest you choose 0.25 pad with a 0.125 hole. Okay, so that is the first thing that you have to do. Okay, next is the is what else? Okay, the connector. Okay, for this circuit, I have two connector. Let me search the component need first. Okay, so I have three connector. Okay, but I show two first. Okay, so you can see this is the 2600 PCB head connector. This is very common for electronic. Okay, this one, if not mistaken, is only 3 ampere, very low current only. So if you want to use this, you have to use it for the electronic part. But if your current is much more higher, okay, like circuit, power electronic circuit, you have to use terminal block. Okay, this one I already mentioned also. So you can see it's almost 20 ampere. Okay, so you can see here, this is a very small current, and you can see here, okay, this is the component. Okay, so I put here power supply. Okay, so 0.09 and 0.43. So this is the what you call the component that the hole that is suitable. Okay, so how to choose the hole, I forget to show. Just click here and choose the hole. Okay, so 0.09, what is it? Okay, so 0.09, 0.43. So you just click. Okay, so just put it, and usually it is only 1 point different. So you can see here, this is actually 1 point different. It is standard. Okay, if you look at protoboard, this one is actually 1 hole different. Okay, so that is for the hole. You can put it here, and my suggestion is, this is supply, right? Power supply. I suggest you put it at the top. Why you put it at the top? Because usually this is your protoboard. For example, this is your PCB. Okay, when you want to do the experiment, your power supply is usually at the top. Okay, so if you put the power supply at the top, it's better for you to put this at the top. Okay, depending, you have to look at your experimental setup. Okay, for data, for example, oscilloscope also usually at the top. So I suggest you put this one. For example, this is for data. Okay, for the oscilloscope, I put it at the top also, near the top, so easier to get information. If you put at the bottom, the wire can be crossing. Okay, so that's it for the hole for this kind of connector. But if you use terminal block, this kind of terminal block, because of the higher current and the larger size, this is larger. Okay, you have to use this white. Okay, 0.15, 0.07. Okay, this one I think is much more suitable for this application. Okay, you just click here, 0.15, 0.07. You just click it and you can create it. Okay, so okay, for this one, no, I think this one, yes, this one I use. Okay, 0.15, 0.07. Okay, so that is for this one, for the block terminal. Okay, this one is for PCB header. Okay, that is for hole. And how about the wire? Okay, your wire, you can see here, I choose various size. Okay, for this one, okay, this is just for electronic. So for electronic, I suggest you just use 0.04 inch. Okay, so it is better to use 0.04 inch. Okay, And make sure when you choose this, okay, this is how to choose a wire, and then you choose 0.04 and you choose the bottom. Okay, because you are designing DIP. Okay, DIP type means that you have drill a hole on the component and you have to put the component inside the hole. So you have to use the bottom. This is bottom. This is top. Top is for SMD. Bottom is for DIP. Okay, so this is for power electronic. Okay, so you can just put it, and I suggest you don't put square. Okay, for example this one. Okay, this one is not very good actually. So this one square. Usually in my experience, if you use square like this, okay, this can easily damage. So that's why we do this. Okay, one is much more easy to see. Okay, much more better to see a static value, and another one is just to avoid if you put like this, sometimes the corner will damage. But if you do this, the corner is not too severe and harder to damage, okay, during the etching process. So I suggest you put 45 degree. Okay, easier for you to do etching, something like this. Okay, you can see here, instead of just make a T, okay, which can easily damage, okay, I put something like this. Okay, this is just a limitation of heat transfer and etching process. Okay, so I suggest you do this. Okay, and for the wire, the thick wire, okay, this is for power electronic one. Okay, this one carries a lot of current, so I suggest you use 0.08 or higher. Okay, actually this one, depending on the current, 0.08 is also not enough. Okay, you need to choose larger. For example here, okay, maybe 0.25, okay, something like this. Okay, so it can carry much more current and you don't have any problem for this. But for this circuit, the current is all highest is only 2, so that's why I choose 0.08. But it needs to be thicker. Okay, so maybe 0.02 should be okay also. Okay, if you don't like because of this one is too thick, okay, you can use you can make it small, but then you have to add solder on top of this, okay, just to support the current. Okay, because for UTM, for FKE UTM, if you want to use the heat transfer or printing method, okay, so you have to make sure, okay, that this line is thick. Okay, this one should be okay because it's quite thick. Okay, 0.08 is quite thick, but for this one it's not very good. So this one, when you do this, when you do the heat transfer etching and so on, sometimes this one disconnected. Okay, that's why it needs to be large. Okay, try to avoid small one. Okay, but this one cannot do anything because it use integrated circuit. So when it comes to integrated circuit, you don't have enough space. That's why I do like this. Okay, so this one is not very good because you can see here, this is not it is right angle. So right angle sometimes during the etching or something, it will eat this area. Okay, that is just a limitation. Okay, and for component, you can click here, choose your favorite component. Okay, so you have axial electrolytic, this one capacitor, this one connector, everything is here. Okay, but I usually don't use this. Why? Because this, okay, the pad, this one, the pad is too small. Okay, if you see here, this one, it should be okay because this is 1 watt resistor, but if you choose smaller watt, the pad is smaller. Okay, the pad is quite important during the soldering. Okay, if the pad is too small, your solder cannot be good. Okay, because our soldering tip, okay, on the solder, okay, the soldering tip is not good anymore. It's already very long. So you need to have a very large pad to do this. Okay, so you make you, instead of using the component, for example here, resistor, search for resistor, where is it? Okay, resistor 0.25 watt. Okay, so see, it is very small. Okay, the pad is very small, so when you do the soldering it's not very good. So that's why I just use this one. Okay, that is just a tip for you. And another, this is Arduino. Okay, no need to worry. If you want to make Arduino, it's very difficult to do this because we don't have Arduino in the component here. Maybe the new one, the new software should have it, so you don't have to measure one by one for this. Okay, so what else? Okay, if you have this one is variable resistor. Okay, you have to put it close to you. Okay, go to the bottom because you want to control it, right? So if you want to control something, the controller should be at the bottom, easy for you to control. Okay, and what else? The load. Okay, the controller are usually at the left side. Okay, depend on your computer. Usually you put the computer at the left side and you put the circuit at the right side. Okay, so that's why for mine, the Arduino is here, the controller out is here. Okay, depend on you, either left or right, because you put your computer is usually at the left or at the right. And then this is the load. Okay, the load location, usually I put load at the right. So make sure you design the PCB, you have to make sure the design follows your experimental setup location. Okay, what else for power electronic? Okay, for power electronic, you can see here, this is MOSFET. Okay, MOSFET, you have this one. Okay, if you look here, for MOSFET usually we use TO220. This is a standard. Okay, this one standard. This is a standard MOSFET body. Okay, or MOSFET size. It's called TO220. So you can see here is very small. Okay, and the pad is very small and close together. The problem when I design the power electronic is that when the MOSFET run, this is G, this is D and S, gate, and for the gate and drive usually there will be spark. I don't know why, but they are spark. So the distance you need to add. That's why I use manual pad instead of using the component itself. Okay, you can see back here, the distance is only 1. Okay, this one and this one is only 1. So if manually, it will become 2. And I have to expand the MOSFET leg to ensure to make sure the distance increase. Okay, this is just for safety. Usually did with spark. I don't know why. This one will be spark. G and D. Okay. What else? Okay, another thing you need to consider is inductor. Okay, inductor produce electromagnetic interference, EMI. So make sure when you do the inductor, make sure it is far away from all other components. So for this case, I just put it outside. Okay, so I just create a terminal block here, the terminal block, this one. Okay, this one, and then I just put it outside. Okay, you can also put it inside, but make sure it is far away from capacitor and inductor and other component. Okay, so you can see here I give spaces for the inductor. Make sure nothing is close to the inductor because there will be interference. Either you do this or you create a Faraday cage. Okay, so Faraday cage I think no need because you have to build the Faraday cage itself. Okay, I suggest just put far away. You don't making a product, you just do a research. And then you have to label. Okay, this one is quite important. Make sure you label. Okay, you can be forget because you have designed a lot maybe in your research. So make sure you label what is this. Okay, and make sure you put the positive and negative. Okay, sometimes you forget which one is positive, which one is negative, but if you label it, you don't have to worry. Okay, so all of these you have label properly, positive and negative. For inductor no need lah, inductor don't have polarity, but capacitor you have, so you have to label. So for Arduino, you can see here I label the pin number. Okay, no need to label all, just sum of it, so you can easily determine. So I label 8 and 10, so automatically now I know this one is 8, 9, 10, 11, 12. Okay, this one also I label it A0. Okay, so automatically I know this one is A1, A2. Okay, this is the supply. Okay, so okay, I forget to bring this here. Okay, and what else? Okay, this one for resistor, you can see here 1 kilo ohm. I also put the value here because if for example the circuit broken, I want to change the value, I want to change the resistor, I can just look at the PCB and I know what resistance value I can use. Or you can use the color, no need to worry also. But if you want to label, it's much more better. Okay, and also the watt. This one is 0.5 watt. Resistance usually have watt. Okay, so that one is optional, but for label like this is important. Okay, and then of course you have to give title and version. I suggest to do this. Okay, easy for you to check back. Okay, your design. Okay, and then the function, the name. Okay, and of course it's better for you to put your name. Okay, because when you submit in the PCB, usually in bulk. Okay, PCB lab at P04 level 1, usually in bulk there are a lot of PCB, so if you put your name, it's easier for you to search for it later. Okay, you don't have to remember the circuit, you just look for your name. I suggest you put your own name here, and of course put date. This is just a suggestion. So what else? Okay, and after all you already design everything, okay, like this. Okay, so you can just print it. Okay, so print it only the bottom layer. Okay, and make sure the size is correct. Okay, size is important. Okay, because if you choose the wrong size, it cannot fit. Okay, so after you print, okay, after you print it, you have to test it first. You cannot just directly do this. Okay, so like I said before, you print at the bottom. Okay, this one, file, print, bottom side, because you're using DIP, you have to print at the bottom side. Of course your design is also at the bottom side. Okay, and SMD at the top side, but like I said before, for FKE, UTM, we don't have a good facility for SMD, so I suggest you do the DIP. Okay, so you already designed this, and you have to check whether your design is correct or not. Okay, because this is all software, you have to check one by one. So this is just an additional step. Okay, to ensure that your design is correct, first you have, of course, you have to print it. Okay, print it at the bottom one. Okay, if you use DIP, of course you have to use the bottom one. Okay, and you find some, I forget the name, polystyrene, I think. Okay, so you can take one and then you just put it here. Okay, why you have to do this? Because it is easy for you to check whether your design is correct or not. So for example, this one, okay, I can try to insert it. Okay, should be fit. Okay, and you can see here, I can see it is out of the PCB, so you can adjust it later. So same here, you can check back, okay, whether the component is fit or not. Okay, so maybe this one, okay, put it here. Okay, so this one, put it here. This one, okay, just to make sure all the component is fit. Okay, so you can see it properly. Okay, so this one, okay, and this one. So you can see here I have 2, 1 and 2. Okay, so I don't know whether which one is fit. So because of I do this, I can see that I can delete the extra hole. Okay, So that is why you use this thing to ensure your design is correct. So if you have PCB, for example, this one, okay, for example, this is Arduino. Okay, let me take this. Okay, so I put this. Okay, and then I test it out just to make sure it is can fit. Okay, that is why I suggest you do this. Okay.